Hi everyone, this is page 4 of the Chapter 1 test review for Algebra 1B, starting with number 25. And in number 25, really 25 through 27, are all referring to this table. And when you've got something like this that you're working with, before you even start answering questions, make sure you understand what the table is telling you. So P of X is my population of Philadelphia, and B of X is the population of Boston, where X represents your years. So what these numbers are the populations of these two cities in these years. So when it says find B of 1950, that's asking me to take 1950 and look at Boston, which is 950,000. And what does that number represent? That means there were 950,000 people in Boston in the year 1950. Make sure you include both of those pieces, because when I say B of 1950, there's really two pieces of information there. There's Boston and 1950, so make sure both of those things are in your explanation. Okay. P of 1980 minus B of 1980. So this time, let's see, I guess I'll change my color up. P of 1980 is here, and B of 1980 is here. So it wants you to subtract. This means subtraction. So 1,688,000 minus 787,000 gives me a grand total of 901,000. Now, if you're struggling on what that represents, I want you to think about if I just handed you this table and then subtracted these numbers for you, why would I do that? What does that tell me? Okay, well, that tells me the difference between these two numbers, right? Because that's what subtraction tells you, is the difference. And the only reason I would want to know the difference is to know how many more people were in one city than the other. So when I subtract this, this means there were 901,000 more people in Philadelphia, I'll abbreviate there, than Boston in the year 1980. So in that particular year, there were 901,000 more people living in Philadelphia than there were living in Boston. Okay, let's take a look at this next one. This one wants me to look at B of 1990, right? Okay, so here's B of 1990, and then B of 1980. So it wants me to look at these two numbers. Starting with 1990, that's 736,000. And then I'm subtracting the 787,000. And when it gives me this division by 1990 minus 1980, that's treating those as numbers. So I want to know what is 1,990 minus 1,980. And here's what that's going to give me. Up on the top, I end up with negative 51,000. And on the bottom, I end up with 10. Okay. And then, well, before we move on, let's talk about what each one of those numbers represent. Okay. This negative 51,000, if you think back to the last question we did where it was telling us to subtract, that's telling me, and we're looking, these are both Boston numbers, okay? But this is Boston in 1990, this is Boston in 1980. So it came out negative. What does that tell you? Well, that should tell you that the population is going down, that there were fewer people in 1990 than there were in 1980. So this negative 51,000 means that there was a decrease in population. Move this over some. And this 10 represents the number of years. But I'm not done yet because that wants me to actually divide. So when I divide that, I get negative 5,100. And that means that there were 5,100 people 5,100 people leaving Boston per year. That's why we would divide by 10, because that would give us an idea of how many people are we losing each year. Now, if that number were positive up on top, that would be the number that we're increasing per year. But really the important part I want you to get is the per year. Okay, that when you do this division, what you're really figuring out is, okay, so I lost this many people over a time span of 10 years. If I divide that out, how many people am I losing each year? Okay, on to number 28. This one goes away from that table. A baby blue whale weighs 4,000 pounds at birth, gains 200 pounds per day while nursing. Write and solve an equation to find the number of days a baby whale could have been nursing if it weighs 14,000 pounds. Well, to write and solve an equation, first I need my variables. I want to know, what am I trying to find? I'm trying to find the number of days a baby whale would have to nurse. Okay, so now when I go to write my equation, I'm going to start with this 4,000. I'm gaining 200 pounds per day. So I'm adding 200 pounds, and then per day, well, I just said days was going to be my variable, so that's going to be my x. And I want to know, when would that equal, because I want the weight to be 14,000 pounds. So when does that equal 14,000? Okay, I'm going to solve that just like any other algebraic equation. Let's subtract 4,000. I'm going to have to move off to the side here. So now I have 200x equals 10,000. Let's divide by 200. Oh, I should have done that in orange if I was going to stick to my color coding. Sorry about that. X is going to equal 50. So that's 50 days that the whale would have to nurse. Okay. 29. Oh, 29 is similar to the question where I asked you to figure out how old I was on our quiz. Blow that up a little bit. So the first thing I would do, because it's the first thing I always do, is I would define my variable. What am I trying to find here? I'm trying to find the grand total number of students. So x is going to be my number of students. Okay, so let's start putting our pieces together here. I have 2/5 of the students that are sophomores. So 2/5 of the students are sophomores. 1/3 of the students are juniors. So I have 1/3 of the students are juniors. And then I actually know how many seniors I have. I have 320 seniors. Okay, so if I add together sophomores, juniors, and seniors, because this school is only grades 10 through 12. Sophomores, juniors, seniors. If I add those together, it should equal my entire student body, which I just said was going to be x. So I'm going to set this equal to x. Some of you missed that on the quiz, by the way, what you're supposed to set that equal to. It has to equal whatever the total is that you're trying to find. Okay, now I'm going to go through and multiply by something that'll cancel out these ugly fractions. 5 and 3 both go into 15. So I'm going to multiply my entire equation by 15. Oops. Be careful when you're doing that. When you're doing this multiplication, 15 times 2 over 5, you're really doing 15 times 2, so that'd be 30, divided by 5, which would give you 6. I actually might move down to the bottom here. Oh, I don't know why that 15 stayed there. Weird. just rewrite it. Okay, so 15 times 2 is 30. 30 divided by 5 is 6, so now I have 6x. Here, 15 times... oh, it's late. Sorry about that. 15 times 1/3, that's 15 times 1, which is 15, divided by 3 is 5. So that's going to become 5x. The thing that people forget all the time is that this 15 also needs to be multiplied by the 320. So 15 times 320 is equal to 4,800. Oops. And then, even if you remember that, you also have to remember that the 15 needs to be multiplied by this x down here. So every single piece of your equation gets a 15. So now this is going to be 15x. Now I can solve it. So 6 and 5 together make 11x plus 4,800 equals 15x. Let's subtract 11x from each side. End up with 4,800 equals 4x. Divide by 4. Divide by 4. Oops. And you should end up with x equals 1,200 students. Okay? That's how you would tackle a problem like that one. And then let's look at number 30. Number 30, I just want you to practice writing these things in words. So you've got x over 2 minus 3. Actually, the words I just said would be a perfectly fine way to write that in words. Again, you're looking for your operation words. So division, we could just say x over 2. You could also say x divided by 2. You could say the quotient of x and 2. I could say x over 2 minus 3. That would be an okay way to say it. There's a verbal expression. Could also say the difference, because that's my subtraction, of x over 2, because that kind of keeps all of that together, and 3. Okay. Trying to think of some other ways you could say that. You could say half of x, take away 3, something along those lines. So just any combination of those expression words is what you want to look at for that one. Okay, you're almost there. One page to go.